Okay, so what I've done is I've just made a little practice worksheet to practice writing numbers in scientific notation, and also to put numbers in with a certain number of significant figures. So this is something that we'll just automatically do when we're solving problems and doing calculations for the rest of the quarter. So I just want to take some time to practice. If you want to pause and write this down and see if you can do it on your own and then go through it with me. Anytime we're doing calculations like this together, I would always recommend that a day or so later you come back and try to do it on your own. Make sure that you can do it by yourself, because there is a big difference between being able to follow along and it making sense versus coming to it without the instructions and then knowing what to do. So here we go. We're going to put these numbers in scientific notation. So how do we do scientific notation? So we put a number in scientific notation by making the number, moving the decimal point so that the number is between 1 and 10. And then we count the number of decimal places we've moved the decimal either to the left, would be a positive exponent, or to the right, which would be a negative exponent. So I'm going to just work through some of these. So here's the decimal place right here. I'm going to move it 1, 2, 3 places to the left, which means this is a positive exponent. So my answer is going to be 3.576 times 10 to the third milligrams. So that's that number in scientific notation. The decimal always goes to the right of the first non-zero digit, making this number between 1 and 10. So 3.5, and then the exponent here tells you the number of places you moved the decimal place, and then the unit. We don't care about significant figures here. We're just writing these numbers from what we call standard notation into what we call here scientific notation. So let's do another one. So I know I want the decimal place to be here to make this number 3.62 between 1 and 10. So I'm going to move the decimal place 1, 2, 3 places. This time I moved it to the right, which means it's going to be a negative exponent. So this number would be 3.62 times 10 to the negative 3 meters. So I moved the decimal point 1, 2, 3 places to the right, and now it's a negative exponent. Here, 75 degrees Celsius, here's my decimal place. I'm moving it 1 place to the left, 7.5 times 10 to the first, because I moved it 1 place, degrees Celsius. Here, 1, 2, 3, 4, 5. 3.62375 times 10 to the fifth miles. Here I'm going to move it 1, 2 places to the right, so it's going to be 1.5 times 10 to the negative 2 kilograms. Here I'm going to move it 1 place to the right, so it's 1.632 times 10 to the negative first seconds. And then here I want to move it 1 place to the left, 3.003 times 10 to the first minutes. So this is how we convert numbers from what we call standard notation into scientific notation. So we move the decimal place so that it is to the right of the first non-zero number, and then we use the exponent to tell us how many places we moved it. So a positive exponent means you moved the decimal place to the left. A negative exponent means you moved the decimal place to the right. We will use scientific notation a lot in this class because a lot of the quantities that we'll be dealing with in chemistry are either really big numbers or very small numbers. So we will use a lot of scientific notation. So now let's talk about significant figures. So I should have said, write these numbers in scientific notation with 3, or let's just do with 3 significant figures, not with scientific notation. So we will do a combination of both at some point, and I'll do a lot more practice calculations for you to see examples of that, but here let's just do a little more practice with significant figures. So again, if you want to pause and do this, and then we can go through it. So this says write these numbers with 3 significant figures. So this is really all about rounding. So we said 3 significant figures. So 1, 2, 3. These numbers are significant because they're all not 0. So then you look at the number after the last number that's significant, and it's a 9. If this number is 5 or higher, then you round up. And if it is 4 or lower, then you round down. So the way that we write this number with 3 significant figures is 7,460. Remember, this number now has 3 significant figures. It had 4, now we're writing it with 3. This 0 is essentially just a placeholder, and it is not significant because it's a trailing 0 with no decimal place. What you cannot do is just write 646. 646 is not the same number as this. This number is this number with 3 significant figures. You have to add a 0 as a placeholder, even though it's not a significant figure. So 7,459 grams with 3 significant figures is 7,460 grams. Let's do another one. I'm going to write this number with 3 significant figures. I'm going to do the same thing. 1, 2, 3. These numbers are significant. Then I look to the number to the right of the last significant figure and see if it is 5 or above, and we would round up, or 4 or below, and we would round down. So it's below, so we're going to round down. So I'm going to say 36,500 meters. So these two essentially just become zeros as placeholders. This number has 5 significant figures. Writing it with 3 significant figures changes it to this. Okay, 1, 2, 3. This number is 4 or below, so this becomes 0.0367. I can't put a 0 there, because if I put a 0 there, that 0 would be significant because it's after a decimal place. So in this case, it just gets dropped. So that's the difference between these two, is that this is after a decimal place. Putting a 0 here, 0.03670 would make this have 4 significant figures because there's a decimal place here. This 0 before the non-zero number is not significant. The 0 after the significant figure would be significant. So this is the correct way. This was kind of tricky, 9.99 kilometers. So 1, 2, 3, these are all significant. There's nothing we need to do here. 9.99 kilometers. I'm going to add another one down here at the bottom. 9.999 kilometers. Let's do that one at the end. Okay, 1, 2, 3. I look at this one. It is 5 or above. So I'm going to round this 3 up to a 4. So I'm going to say 65.4 degrees Fahrenheit is this number in 3 significant figures. Here, 1, 2, 3. This number is 5 or above, so I'm going to round it up, 124 milligrams. So now let's look at this one. 1, 2, 3. I'm going to round it up. So if I round this up, 9.99 rounded up, I'm going to get 10. But I can't just say 10 because 10 only has 1 significant figure, right? Because this 0 has no decimal place, and trailing zeros with no decimal place are not significant, and I need 3 significant figures. So the way to have 3 significant figures is to say 10.0. When I put this decimal place here, this 0 is now significant, and this 0 is now significant. Now I have a number with 3 significant figures. So this takes some practice, and every single calculation that we will do in chemistry, we will give the answer with the correct number of significant figures. So I will always talk about how I determine what number I end up with. For a correct answer in this course, your math needs to be correct when you're calculating something. Your answer also has to have the correct number of significant figures, and you have to have the unit. So all of those pieces are important whenever you are calculating a quantity in chemistry. So practice these. There's lots of other examples to look up online. I can always provide more help more blank worksheets and stuff like that if you are looking for more practice. I would encourage you to come back to this in a few days, do it again, make sure you can do it on your own.